we're going to look at specific polygons now. And so our main focus this unit is going to be quadrilaterals. Now, quadrilaterals is just a longer name for four-sided figures. You guys have seen almost all of these before. You just may not have known all of these specific properties and been able to apply them to geometry. So let's take a look. The first quadrilateral we're going to look at is a parallelogram. And something you may not notice or may not know about parallelograms is that they're kind of the building blocks for all of the area formulas. So they're kind of like the building blocks for almost every single shape. So a parallelogram is going to have opposite sides or congruent, parallel, opposite sides. So if we have a line here and a line here, those two are going to be parallel and they're going to be the same length. And then we also have another set of parallel lines that are going to be congruent as well, and they're opposite of each other. Now, if you'll kind of dig back in your memory, you'll remember that when we had a parallel line cut by a transversal, then we had some congruent angles here. So basically opposite angles are going to be congruent. So this angle is going to be congruent to this angle, and then this angle is going to be congruent to this angle. They're also going to be supplementary. So just like the same side interior, that's basically what we have going on here is we have same side interior. So opposite sides are going to be, or opposite angles are going to be congruent. And use that little congruent sign there. And then we also have, I'm going to call those adjacent angles are going to be supplementary. All right, so remember supplementary just means that they're going to add up to be 180 degrees. So they're right next to each other, they'll add up to be 180. All right, the next one we're going to look at is a rectangle. A rectangle, by definition, actually ends up being a parallelogram, but not all parallelograms are are rectangles, because rectangles must have right angles, and a parallelogram, that's not a condition. So when I have a rectangle, I have opposite sides that are congruent and they're parallel, and then I have another set that are congruent and parallel as well. So these are parallel to each other and they're congruent. These are as well. But the only stipulation now is that all of the angles in a rectangle must be 90 degrees. So I'm going to word it the same way as a parallelogram: congruent, parallel, opposite sides, and then also all angles are 90 degrees. So these are okay. So you guys have probably dealt with squares before. And so now let's talk about a rhombus. So a rhombus is a parallelogram, except it's a special parallelogram. It's a parallelogram where all the sides are the same. So it's kind of like a square parallelogram. And I don't know, but that's how I have it in my head, is that all the sides are going to be congruent and you have still opposite sides are going to be parallel. But the reason why rhombus and a square are different is because not all the angles have to be congruent in a rhombus. So a rhombus, if we have two parallel sides like such, and then we have two sides that go this way, these two are going to be parallel, and then the two opposite sides as well. And then also all these sides are going to measure to be the same there. Another thing we didn't talk about with the rhombus that is still true about the rhombus is that the opposite angles are going to be congruent and adjacent angles are going to be supplementary. So I kind of did some abbreviation. So I did OPP for opposite, and then SUP for supplementary. All right, now we have a kite. So with a kite, we are going to have two sides that are adjacent sides are going to be congruent this time instead of opposite sides. So here and here. So this is a kite. So this side is going to be equal to this side, and this is equal to this side as well. So we have let's see, I don't know, we don't have, I'll say two pairs of congruent sides. I may not say adjacent sides because they're right, like they're sometimes right next to each other. Like this, let's see, this line and this line are right next to each other. I'll call those adjacent, but they're really not. I mean, they are adjacent, but they're not congruent. So we have two pairs of congruent sides. And then also something else about a kite is that the angle where the two sides meet that are not congruent, those angles are going to be the same. So I said angles where non-congruent sides meet are congruent. So those two angles that are opposite of each other. All right, and then lastly, a trapezoid. So there's several different types of trapezoids, but I'm just going to show you and talk about an isosceles trapezoid. So when we talk about isosceles trapezoid, that is going to be where you have the two slanted lines are going to be congruent. And with a trapezoid, the only stipulation for a trapezoid is going to be where these two lines are parallel. So just one pair of parallel lines. And then for an isosceles, it's going to have the two, I would say, slants are going to be equal. All right, that's only for an isosceles. That's not for every single trapezoid. Okay. All right, whew, that's a lot. But now let's look and see how this applies to some problems here. So we have parallelogram LNST is shown here. We're going to find the value of A and B. So what we know about parallelograms, remember we have two parallel lines. We know something about the angles, all that good stuff, but angles aren't going to help us here. We're just looking at sides. Opposite sides are going to be congruent. So these two are going to be congruent as well as NT and LS. So I know that 3b plus 2 is going to be equal to 4b minus 2. And so therefore, I'm going to move I'm going to move my 4 over. And then I will subtract 2 from each side. So I end up with negative b is equal to negative 4. So that negative 1, I didn't really need it. I just wrote it there to begin with. Then I'll divide by negative 1 because I need to find out what just b is, not what negative b is. So b is going to be equal to 4. And then now I'm going to figure out the value of a. So 5a plus 4 has to be equal to 3a plus 8. And so I'll move over my 3a. And so 2a plus 4 is equal to 8. And then I'm going to subtract 4 from each side. And I get 2a is equal to 4, then divide by 2 on each side, and a is equal to 2. And I can stop there since it's just asking for the value of a and b. Now let's look at a parallelogram, but looking at the angle measures. So what we have here is that we have a parallelogram and two angles. Now, those, I don't even call them base angles, those angles at the bottom of the parallelogram, those are going to be supplementary because remember when we have parallel lines, like these two cut by a transversal, this angle and this angle are going to end up being supplementary. So I'm just going to have 3x plus 50 plus 2x minus 10 is equal to 180. So then I'm just going to get my x's together. So that's going to make 5x plus 40, because 50 plus negative 10, or 50 minus 10 is going to be 40, is equal to 180. Then subtract 40 from each side. And so 5x equals 140. And then lastly, I will divide by 5 on each side, and I'm going to get 28. Now, I'm not done, because it didn't ask for the value of x, it asked for the measure of angle S. So the measure of angle S over here is going to be 3. I'm going to replace this x with 28. So 3 times 28 plus 50 is going to be the measure of angle S. So 3 times 28 is going to be 84 plus 50, and that's going to be the measure of angle S. So that's 134. And that is the measure of angle S. So we couldn't stop with just X. So make sure you're answering what it's asking for. Example 3 has a trapezoid. Now, this is that special trapezoid that we were talking about earlier. This is one where those slants are going to be congruent. So that's an isosceles trapezoid. So I know that CD is congruent to BA. And it's just asking for the value of X. So I don't have to do anything at the end and go back and plug it in. So I'm going to have 3x minus 3 is equal to x plus 5. But I know you're thinking, whoa, what happened to x minus 1? Well, we don't need that piece, okay, because it's not part of my congruent pieces. So really, you don't need that piece at all. That's just there as a distractor. All right, so now going through and solving for x, I'll subtract x from each side. So 2x minus 3 is equal to 5. And then I'll add 3 to both sides. And so we have 2x is equal to 8. And then lastly, divide by 2, and x is equal to 4. All right. So not asking for a measurement, just asking for the value of x, stopping there. And then the last one is talking about the angle measures for a kite. So the thing that you need to remember about a kite is that where the two non-congruent angles or two non-congruent sides meet, there's two of them. There's two angles there, J and L, and those are going to be congruent. So I know that, so kind of have to go back to last lesson. I know the interior angles add up to be 180 times the number of sides minus 2. So that's 180 times 2, so that's 360. So I know that the inside angles, interior angles, all add up to be 360. So I'm going to call J and L, both of those are just going to be X's there. So I'm going to have 44 plus 80 plus X is equal to 360. So then I'll add my constants and my X's together. So I'm going to end up with 124 plus 2x is equal to 360. And then subtract 124 from each side. And so 2x is going to be equal to 236. And then lastly, divide by 2. And so x is equal to 118 degrees. Now, this is because the entire angle ends up being that. So there's not an expression there in place of J and L, so I don't have to go back and plug it in. That's just going to be the angle measure. So it's 118. So lots of properties of quadrilaterals, ones you're probably pretty familiar with, but just keeping those in mind, like anything that's congruent, supplementary, angles that are congruent, that kind of sort of thing. And just keep those and keep this paper kind of handy so that you can refer back to it if you need to. And that's it. So now it's your turn to practice these properties with your skill check.